So we've developed our methodology and our framework for tackling crystallographic directions, but now we need to get into planes. So whereas we use these square brackets to indicate directions and then our, little these for to denote families of directions, we're going to use this to denote planes and then these squiggly brackets to denote families of planes. But let's go ahead and get started. So let's look at how we can identify first and then how we can draw planes. So again, still have my coordinate system here. Let's look at this top. This is a plane. So how can we determine what are the HKL indices of this plane? So remember, HKL 1, 2, 3, X, Y, Z. How can we determine these? Well, what we have to do is we have to look for where's the plane intercepting here, here, or here. These axes. And they continue on into infinity as well. So, is this plane intersecting X? No, right? Like we're not intersecting like here. What about Y or K? No. What about Z? Yes, or L. So my z-intercept is going to be equal to 1. To get my L indice, so my h is simply 1 over my x-intercept. My k is going to be 1 over my y-intercept. My L is going to be 1 over my z-intercept. What's my intercept, or where am I intercepting at x? Well, I'm not intercepting, so basically it'll intercept at infinity. So that makes my h 0, my k 0, and my L is just going to be 1. Voila. So far, so good. Let's do another one. What about, let's do this. What about this plane? What's my x-intercept? 1. What's my y-intercept? 1. What's my z-intercept? It's not cutting through. It's infinity. So my HKL, 1, 1, 0. Not too bad, right? Let's keep going. What about this? Boom, boom, boom. What's my x-intercept? 1. What's my y-intercept? 1. Z, 1. 1, 1, 1. Piece of cake, right? You should never doubt my ability to ask, to get some interesting questions going. What about, actually, before we go into that, what about this plane? Actually, here, sorry, let me redo this. What about this plane? Where's my x-intercept? It's infinity. Y, infinity. What's my z-intercept here? It's a half. So I get 0, 0, and remember, it's the reciprocal. So it's not a half, not 1, it's 2 here. So we have to flip it. All right. Now, what about this plane? What's going on here? Well, here I'm intercepting x, y, and z at 0. I can't have infinite, infinite, infinite plane. So when your plane intercepts your origin, your original origin, as we always define, we have to reset and define a new origin that is not touching this plane. So I'm going to set, and we should always denote this. Got to reset my guy. Oops. Looks like I'm going to have to... Oh, this pen is very sensitive. Sometimes either I press a button or it's disconnecting. I need to feed it some power quickly. Reconnect. There it is. We need to reset our origin. So I'm going to reset this as my O prime. So this is now my new X, Y, or X, Z, and Y. So from here, I ask myself, where's the plane intersect? X? No, that's infinity. Y? Nope. What about Z? It's not intercepting 1, but it's intercepting me at -1. So my plane is 0, 0, 1 hat. Excellent. Now, what about drawing? What if I asked you, let's say I asked you to draw 1, 2, 0 plane. If we're drawing, what's my x-intercept? 1, right? Because this is my HKL indice. What's my y-intercept? Remember, I have to flip it, so it's a half. And z is infinite. So what I'm going to do is 1 here for my origin, a half here. I could reset my origin, redraw it here. So I could pretend like this is my new origin. I can do the same indices. And there we go. What about if I were to draw? So you see, if we have 2 indices, then we're going to have, some type of rectangular system. What if I try to draw 1? Actually, let's not do 1. Let's do 2, 0, 0. So I know this is going to be square, right? So it's gonna intercept at x equals to half here. Then if I would reset my origin here, it's a half here, and this holds. This is true, even if my origin was here or if my origin was here. What about something? What about if I have 1, 0, 2? This is where things kind of get a little bit difficult. Once you see a negative in play, you want to start out redefining your origin. So I know that my z-intercept is going to be at -1/2. My y is going to be infinite, and my x is going to be 1. So I need something, my origin at the top. So I'm going to redefine my origin here at the top. So here's my new there, boom, boom. So still, from here, where do I intercept x? Right there. I intercept here at -1/2. And I'm going to connect. If I were to move my origin here, it would be the same thing. Here, and then I could just connect. So once you see that negative, you need to reset that origin immediately. Now, the nice thing, what happens if you have, for example, what if it's 1, 2, 1? Well, all I'd have to do is just do 1, half here, 1, connect. If it's 3, it's going to be a triangle of some form. Even if it's complicated, let's add a complication here. Oops, let me just erasing it here. So remember, once I see that negative, I need to think about where can I so I know that I'm going to have 1, 1 intercept, and -1/2. So basically, I need to move this, so I need to move it over here, right? Because I need to go left. So this will be my new x, this will be my new y, this will be my new z. So if I do this, intercept here, 1, 1, and then -1/2 would be here. So I would just do. There you go. Planes shouldn't be too disconcerting. And it's the same thing. We have a family of 1, 0, 0 planes that are crystallographic equivalent. We have a family of 1, 1, 0 planes that are crystallographic equivalent. We have a family of 1, 1, 1 planes that are also crystallographically equivalent. So these are directions, planes. Next time, we're going to get into our first structure, which is simple cubic, and all the fun things that we are going to measure there. So see you all next time. Thanks. Bye.